Okay. Hello, guys, and thank and thank
And
and for everyone. Uh, thanks everyone for coming here and listen to my workshop, and also welcome to my workshop about the formal verification of smart contract. Actually, today there will be no coding alone, and we are going to cover a basic introduction about formal verification and smart contract audit. So in general, we'll discuss some uh, common security knowledge, and any framework should be in applica- in applicable, and we will not coding anything. Uh, the ability to read some codes is enough for this workshop. And this workshop will be about 40 minutes or an hour. So you can grab a cup of coffee and take some notes if you would like to. And I hope you can enjoy my workshop. So let's now start it. And let me share the screen. So so let me do a quick introduction of myself. So I'm Eaton Pan, and I'm working as a security analyst in Bilson. So Bilson is a security company founded in 2018, and we have audited about 3,000 smart contracts and also provide security service for many crypto projects and also VASPS. And you can see my Twitter handle and my Telegram handle here. So feel free to reach me out on Twitter or Telegram. And it's the best way, I think, that we can discuss some interesting topic about smart contracts and also anything about security. So let's do a quick agenda. So as I said today, I will talk about vulnerability detection techniques, especially formal verification, and also some common knowledge about smart contract audits to help you guys, especially developers, to make your projects more secure. So first, we will go through some very common used vulnerability detection technology. So, uh, so, uh, why we need to use detection techniques? The the most important reason is that there are many security issues in the smart contracts and blockchains. So smart contract has some features or differences between from the traditional programs. So when a smart contract is developed and deployed on the blockchain, it's very difficult for developers to fix vulnerabilities or to update a smart contract. And also, there are many blockchain platforms which is not well developed and has some emerging technologies. So let's do a quick recap. So in 2022, the Warm Home across bridge project, especially in developed on Solana. So so it was hacked because of there is a vulnerability in the Solana SDK, and recently there is BTC Layer 2 stacks, which has some issues with its programming language clarity and caused its consensus to collapse and transform to proof of burn. So that's why we need to develop vulnerability detections and techniques to help developers and auditors to find vulnerabilities. And also, smart contract is open source. I guess you guys all know that. And hackers are very motivated to find bugs and also the security issues in the smart contract for them to make profits. And so due to these reasons, there are many security vulnerabilities in the smart contract, and there is an urgent need for us to to develop vulnerability detection techniques. And there are some very common vulnerabilities like reentrancy attacks or integer overflow that I will not explain in details. And there are also some very complicated bugs that are hard to find and hard to detect. And for example, the multi-contract interactions. So many hackers or arbitrators to make profits through multi-contracts. And if there are some contracts which has some vulnerabilities, hackers can use flash loan to drain the funds of a smart contract. So we just introduced some vulnerabilities and the harms the vulnerabilities bring. And there are three often used vulnerabilities detection technologies. So the first one is static analysis. So which is very simple, and developers just used static tools to help them to find bugs in their codes. But stack analysis is easy to have false positives, and so the developers needs to clarify the warnings and the errors by himself or herself. So, and the dynamic analysis. So dynamic analysis is often used in development and audits. So programmers will design test cases to help them to find bugs. But dynamic analysis has a higher accuracy than the static analysis, but it can also have some false positives. So here comes our main topic. So formal verification. So it is strictly proof that the functions you develop is correct and safe, but it's difficult to do a formal verification, and it always costly. So security problems are very complicated and diverse, and security companies and also developers are used many testing techniques to help them to find bugs. So developers also use function testing in their development. Some developers will choose to use the static testing and also dynamic testings to help them find bugs. And the security companies will use static testing and fuzz testings and also formal verifications to find bugs. And after all these testings, the smart contract will be developed, will be deployed on the blockchain. And here comes uh, the the capability of each testing. So as we just said, static testing, which has some false positives that uh, that across the uh, boundaries of all the vulnerabilities, and the the manual security audits will find bugs that formal verification and fast testing cannot detect. And in practice, in theory, formal verification is the will contain fast testings. And so even though all these testings are used, so we cannot find all the vulnerabilities and fix them. And formal verification is used to find bugs that are hard to be found by testings, especially for static testing and dynamic testing. And we will elaborate formal verification process in details later. So here comes the formal verification and fuzzing. So in theory, so formal verification contains fuzzing, the fuzz testings, but in practice, formal verification and fuzzing will has some intersections. And Bilson uses formal verification and fuzzing in our detection tools. So there are three shortcomings of formal verification. So first, when you use formal verification, there will be some nonlinear computations for you, and for formal verification tools to compute. And also there are some timing out problems, which will which you will meet when you solving a symbolic constraint. And also if your codes are very complicated, there will be some state path explosion, since your codes are very complicated and there are many executable paths for the formal verification tools to conduct. So that's why the formal verification is costly. Okay, so we will discuss formal verification in details. So formal verification is about what to do. So it tells you the code. It tells you what the codes should do, not how to do. So it usually uses formal specification to express the code functionality or the security attributes in a mathematical quantitative manners. Let's take a simple example. I will give about 1 or 2 minutes for you to read the transfer functions. So I guess it's very easy. So there are two addresses, the sender and the recipient, and the amount that the sender will send. So so you guys can read the codes. So in testings, so maybe developers will say after transfer, the recipient should add the amount to the to its address, and the sender will reduce the amount. And also here comes a simple test, and and it proves that the codes are correct. Uh, since you guys cannot interact with me, so I will continue. So so the simple test case is very is too simple to find some issues. So if you use uh, if the sender is Alice and the recipient is Alice, what will we get? So if if the sender address and the recipient address are the same, so we will find the so we will find the Alice the balance of Alice address will increase, and it's a it's, it's a very serious bug in the transfer functions. So 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 we need to describe the function in a in a quant, in a quantitative analysis. So in a quantitative way, since the sender will send some amount to the recipient, so the amount before before the transfer, the amount of the sender and the recipient will equal to that of the sender and the recipient after transfer, right? So here is the formal specification. So the new balance of the sender and the new balance of the recipient will equal to the previous the addition of sender and the recipient. So after we write the formal specification, we will find the code has some bugs, and we need to fix the code. So I will show the reasoning process later. So we need to first check the sender check if the sender has the amount to send, and then we will update the sender's balance and the recipient balance. So you can compare the fixed code and the previous code. So the previous code has the problem with the intermediate variables. So you can use the formal specification to find the bugs, and also you can use fuzzing. So as we just previously showed, so fuzzing and the formal verification has the intersection in practice. So you can find the bugs using formal verification or fuzzing. So if you are using fuzzing to detect the vulnerabilities, you cannot say the code is bug free. But if you use formal verification to describe the code in a mathematical way, so you can prove that the code is correct. So here is the mathematical description of the transfer function. So for any senders and any recipient, and for any transferred amount, the new balance of the sender and the recipient will equal to the previous balance of the sender and the recipient. So if you are using formal verification, you can say the code is correct and is error free or bug free. Okay, so the formal reasoning, so we will use OR logic. So it contains three components. So OR logic has the preconditions and post-conditions, and between the preconditions and post-condition, there will be arbitrary executable paths of your codes. So so the the correctness the correctness of your function depends on the three components, and and the and and if your function is partially correct if the precondition is true just before the function, just before the executable path uh, runs, and after the execution, the post condition becomes true. So so uh, so in this way, your function is correct, is partially correct, and the com- and the totally correct the totally correctness of your function will be determined by the partially correctness plus the guarantee of your function, a guaranteed termination of your function. I guess hope you guys uh, can understand the whole logic. So it's the basics of the formal reasoning and the formal verification. So uh, so so simply speaking, so you need to have a guaranteed termination of your function, and uh, the precondition should be true before your function runs, and the post condition will become true after the function runs. So that's the whole logic, and prove the function is correct, totally correct. And here we will use the formal reasoning uh, on the transfer functions. So uh, so uh, so the senders will have the senders has the balance has the sender balance, and the recipient has has his or her original balance. So uh, I guess so we will first check the balance of the sender. It, so if it's greater than or equal to the amount, right? So if the sender's balance is less than the amount, so we will not execute anything, and the state is the same. Is the same as before, and we will get the oh, where is my mouse? Oh, okay. So we will get uh, the formal specification correct, right? So this executable path is correct, and also if the sender's balance is greater than the amount, so we'll update the sender's amount and also the recipient amount, and we will find so and we will also find the formal specification is correct, right? And so uh, so so the fixed code, after we execute all his executable paths, we will find it meets the formal specification, and then we can say the code is bug free. And we will see more common examples and easy examples later. And so let's do a so here is the practical application and static testing. So static testing, as we just said before, so it's very easy to for developers and also auditors to use to find common vulnerabilities. And we use the static testing in our Wilson VAS, which is a detection tool for us to find smart contract vulnerabilities. And for the formal verification, so in theory, we will say it will prove the codes are error-free or bug-free, and the difficulty of the formal verification is the computability, since if your codes are very complicated, the computability is very hard to reach. And also, in theory, we expect that formal verification will replace security audits. But unfortunately, formal verification is can only be used to find bugs which are very difficult to be found by other testing techniques. And because we need to write a formal specification and use formal verification tools to find bugs. So in theory, formal verification can find all the bugs and prove the codes are correct. But in practice, is to find bugs that is used to find bugs and improve the security audits. So there is a gap between the theory and the practice. And Wilson used the hybrid detection system. So as I just said before, so we will use formal verification and fast testing to use these two techniques to help our auditors to find the vulnerabilities in the smart contract. Oh, sorry. Okay, so how to write formal specifications? So usually we will find the invariants. Here are some invariants examples. For example, resources completeness. So how developers manage the resources, and how developers write codes to update the resources. The transfer function is an example. So, and also the limited supply of tokens, and also authorization. So, what operations can be done by authorized users, and what operations cannot be done by some unauthorized users. So here is the invariance for us to write formal specifications and to prove if the functions are correct. So we will see an example. See another example. So here is a GameFi project. We audited before, and the code is about the battle between two wizards. So I will give 2 minutes for you guys to read the codes and to see if you can find the bugs. Okay.
So we're waiting for the questions. Yep.
Okay. Daria,
Yeah,
well,
yeah, I'm here. So we are waiting for the questions from the audience, right? Or no?
oh, okay. I, if they, can they say, can they open their mic, or I, since I just give them some time to read the code, so can
Ah,
can
I
they?
see, I see. So we need to read the code and then you will continue, yeah?
Yeah, yeah. So I hope they can follow me, since it may be difficult or boring.
Okay.
Okay, okay. So uh, so so the so the so the main point is about the update power. As I just said before, the resource completeness. Uh, okay, can okay. Uh, I hope you guys can read. Uh, Focus on the update power. So it's about resources completeness. So how the how the functions manage the power of the wizards. And okay, we will see that. So it will give it will give give the power of wizard 2 to wizard 1, right? And I guess you have find the bugs, since it is it's almost the same as the transfer functions, right? And also we will find uh, the power, that the updated power, the addition of wizard 1 and wizard 2 should be equal to the previous addition of wizard 1 and wizard 2, right? So uh, it's almost the same as the transfer function uh, we just mentioned before, right? So this is the invariance. So the power should just transfer from one wizard to another, just like the transfer function. So we can first find the invariance and then write the formal specification. So after you write uh, after you write the formal specification and and spot the features of the update power function. So we can use the same test case, just like the transfer function, right? So if the wizard if the wizard uh, fights against himself or herself, there comes the problem, right? So to fix the code, we just need to we just need to add a line of code that to check if the wizard should be wizard 1 should not equal to the should not be the wizard 2, right? So then the codes are correct. Okay, let's give another specific example, since our the tone hackathon is about the DeFi and also data analytics. And let's take a Uniswap pricing model. So Uniswap V2 or V3 uses the constant product, right? I guess everybody here knows. So the constant product formula is the basics of the pricing model. And if no fees, so if no fees, so the uh, the formula will be like this, right? But if we take fees into consideration, we will find the k prime will should be bigger to the previous k, right? Uh, since the liquid proof uh, the liquidity providers will charge some fees, and the fees will be remained into the pools, right? Since the fees will be remained into the liquidity pool, so the K prime should be bigger than K, right? I guess you can understand. So here, so this is the invariant that we will find, right? So the constant, the product of two tokens after swap should always be greater than or equal to, right? Uh, or equal to the value of K, and also so after we write the invariant, so we can use the invariant to write the formal specification here. Oh, so where is my mouse? So so we can use the invariant to write the formal specification, and we can uh, we can we can check the codes of smart contracts, of DeFi smart contracts, and to see if there are some bugs on the smart contracts. And here, since there will be some multiplication computation, so it may have the timeout problems. You can use the fuzzing to find the bugs. So here is the I guess it's the very typical security issues that happened in the 2022. So it's the K invariance checking. So I guess you guys know the project called Impossible Finance. There are many DeFi projects has the K invariance checking problems. So when he do the swap functions, so the swap function didn't check the K invariance, didn't check the K prime should be greater than or equal to the previous K value, and 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 uh, and the Impossible Finance got hacked. I guess it lost about 500 K dollars in the 2022. Okay, so that's the formal verification, and we can have a quick summarize. So first, you need to find the invariants, and then you can use the invariants to write the formal specification, and then you can use the formal specification to check the codes or the codes and the functions in the smart contract to see if there are any bugs in the smart contract. And if you are hard to if you think it's difficult to write a formal specification just in a short time, you can first try to find the invariance first, and then learn to write the formal specification. And also you can use fuzzing, and fuzzing is a very practical technique for testings and also to find bugs. And the first part that we would like to share with you is the things that you need to know before audit. So in the development, I guess users developers should write test cases and also do testings during their development. And the typical process should be write code, test, and then check the codes that fail to pass the test. and also and upgrade the code and then repeat the whole process. So after you do the testings, so you may want to optimize your code, especially for gas optimize and memory optimize, uh, since it can save some gas fees for users. And also you need to check the code coverage. Uh, Ideally, we developers want to have the code coverage to be 100%, but it's very good to have 90% or 95% of code coverage after you do the testings. And also the document is very important. And I know that I guess all the developers are very bored to write documents, and uh, so I know the I know, and the document is very important because the auditors and also the users uh, want to understand your projects and your codes. The best way is to read the documents, and especially when your project grows very complicated. So for auditors, they are very hard to know know the know the correct business logic of your project and help them to uh, they are very difficult to find the correct business logic of your project, and also it's very time consuming for them to read your code line by line. So if developers can provide a clear documents, that would be very helpful. And also the peer review, I guess, is a common behavior between the developer teams. And then after you are doing all the 5 steps, then you can look for an audit. So in audit we so we also almost every security companies will do the static testing first to find some common issues or warnings or some gas optimization advice for the developers. And then we will use fast testings to find some business logic issues uh, and also do the formal verification to find business logic issues, and especially for the and also the arithmetic logics. So there are many audit services. So first is the audit provided by security companies. So the developers will provide a request for audits, and then the security company will do the audits for the developers. And also the second one is the competitive audits. So the project will provide funds and rewards to attract many auditors, individuals or auditors who are working on security companies to find bugs and submit reports to help the project find bugs. And also the bug bounty programs, which are provided by many projects to reward white hackers to find bugs. So there are 3 main audit services in the crypto market. And here are some tips for the developers. So first, if you are looking for an audit, you need to first confirm the commit hash. So which version of your code needs to be audited, and then you need to confirm the down payment for the smart contract companies and the start date of your audits. So, and second, as I just said, you should have a very clear document. That would be very helpful. Since a clear document can shorten the time of audit and also help the auditors better know your business logic. So, and the third one is that have your codes commented and readable. I guess it's a universal request. And the fourth is to create a communication channel between you guys and the auditors for better communication and a quick response. So the fifth advice is optional. So you can developers can record a video to go through your codes to help the auditors and to help the auditors or your users to quickly and comprehensively understand your business logic. So here are the fifth advice. Here are the 5 advice for you developers to work better with the security companies and also the users. Again, okay. Finally, I would emphasize that audit does not equal to secure. Does not equal to the secure codes. So even though all your codes have passed the audits, even for many security companies, which doesn't mean that your codes are very secure and bug-free. So you need to still pay much attention to your code modification, especially if you update your code or add some new features of your projects. You need to do a comprehensive testings and if the funds are not a problem for you, you can do the audits again to help you secure the projects. Since I guess the typical example is the Ola Finance, which was hacked and lost about $200 million because the teams add just a donation functions. So the security is the security of the project is very difficult to maintain and to help the projects to be bug free. And here is some information about Wilson, and I hope you guys can learn some information of the formal verification and all this. And thanks you guys to bear with my English, since I'm not a native speaker, and I hope you guys can enjoy the workshop. So thanks. I guess my workshop is already complicated. Thank you guys.
Thank you, Eaton, for your speech. And now we are waiting for the questions from the audience. If, I see someone is, if I'm not mistaken, the name of the person is Caleb. I'm really sorry if I have made a mistake. So we have a volunteer who would like to ask a question. Please, you are on air. You can ask your question. Caleb, you should switch on your mic, and then we will.
Okay. Hello, can you hear me?
Cool.
Yeah.
Can you hear me?
Yes.
Okay. Tao, thank you very much for the lecture. I really enjoyed it. I live in Nigeria,
thank you.
and yeah, we don't have access to some of this information you gave out. So I also wanted to ask if I wanted to be an auditor for
yes.
how do I get started? How do I get started as an individual auditor for this project?
Oh, okay. So
yeah, sorry, I don't have any previous knowledge on auditing. I am a final year student of pharmacy, so I really don't know much. I just got into the blockchain space recently, so I want to understand, because I'm not a developer. I don't think I will go into that field. But as an auditor, is there a chance for me to get started at any point? Thank you.
Okay. Thank you, Khalid. If I call you right.
Yes, correct.
If you want to be an individual auditors, there are some resources in the internet, and let me share my screen, and wait a second, and sorry, let me share my screen again. So first, there are some. So first, you need to at least know a type of programming language. That's a necessity for you to be an auditor, since you need to know what the codes will do, and the consequences of after the code execution. So I guess that's the first thing you need to accomplish.
Okay.
And
yeah, I understand you. Are there any links I can get from you directly to these information sources?
I since there is no type box, I cannot get. You can PM me, so send a private message to me.
Okay.
So
I
can share
think that would be good. I also followed you on Twitter. Yeah, so I'll DM you and ask about it still after this class.
Okay. Yes. Thank you for your
thank you very much.
enthusiasm and support. Yes. Thank you.
Yeah, thank you.
Thank you, Caleb, for your question. And we are waiting for another volunteer. Is there anyone who would like to speak? Yeah, I see Tumin, if I'm not mistaken. So we have another person who would like to ask a question. So you are on air right now. You should switch on your mic, and then you can speak.
Yes, thank you so much for the opportunity. A lovely presentation. I guess I'm able to hear me out. Yes, can you hear me?
Yes, can you hear me?
Perfect. Right. So the question is that I understand you guys provide the solutions for EVMs. Is the same for Dawn as well? Do you guys also provide does the company provide auditing specifically for TON as well, or this is specific to EVMs only?
Oh, okay. So the techniques, especially for the formal verification, is applicable for every blockchain smart contract audit. So yes, our company is working on the Solidity and EVM chains, but the techniques is applicable for the Tom network and also other uh, other
Other
other blockchains. Since we are so we have audited some projects built on Polkadot or Near. They are written in Rust or Substrate. So, the programming language is not a problem for the audit. And
and
I hope my answer can.
I understand.
I
I
know
understand.
yes.
Yeah, but my only specific question was that I understand the techniques or the fundamentals of how you guys proceed with any auditing procedure. Yes, I understand that. But let's assume next week or next month, if I reach out to the company for a specific audit for a specific contract which is on TON, will the company be able to help me out or help the company?
Oh, sorry. Can you repeat the question again?
I understand that your company provides help for EVMs. If I want the help for TON specific, is the company willing to provide support for that?
Yes. Yes. We are working on the Func programming language, right? Right now, and so if you are looking for some security advice, you can reach to me or Bilson. You can reach to the Bilson official website. There are official emails for you to ask for security help or the future audits. That's yes, we are. Yes, the Bilson is working on the Tom network audit. Since we are the partner of the Tom hackathons, right? So we are working on the Tom network project audit.
All right, perfect. Thank you so much. I have your information. I will DM you if I have specific needs for it. Thank you for the lecture.
Okay, thank you. To me, yes, I know
yes,
I know the questions that you asked, and if you have some needs for the security suggestions or the security tools on the Tom network, you can you can you can you can DM me, since Bilson is working on the static analysis tools on the Tom network programming. We are also
we are
working on okay, and we are also working on the formal verification on the Tom network.
Yes, thank you. I have your information. I will DM you. Thank you so much.
Yes, thank you.
Thank you for the question and thank you for the answer. So, is there anyone who would like to ask another question? If there is no volunteers, I think that it was a great lecture and it was a nice way to start our weekend with the useful knowledges from our mentor. So yeah, there is no volunteers who would like to ask a question, and Thank you, Eaton, for your lecture and that you have found a time and spent, maybe it is morning, maybe it is evening, maybe it is in the middle of a day with us and share your knowledges about smart contracts and formal verification. So guys, the workshop has ended. I wish you a very happy weekend. Spend your weekend as you wish. Enjoy the summer, and we will upload the recorded video of this workshop in our chat of the hackathon. Also, if you have any questions, you can write them to me or to the Eaton. And on Monday, we will meet on another workshop. So stay tuned and wait for the updates. Thank you so much. Have a nice day. And I think that it is time to goodbye. Maybe Eaton would like to say something.
Okay, thank you, Daria. And I hope you guys can enjoy it and have a nice day. And thank you for Tom Network and AWS for inviting me to give the lecture or prepare a workshop for you guys. It's my honor, and thank you very much. And see you in the next maybe Q&As or tutorial sessions. See you.
Thank you, Eaton. Have a nice day. Bye, everyone.
Bye.